Okay, and that's everything I've got. Let's finish off with an exam style question to see what you'll be facing at the end of the year. Okay, so in this example, I've got a lift. It's got two people inside, two stick people. I'll say cables 1 and 2 have got the same tension in, so they've got a tension of T in each. I've given you the mass of the lift and the mass of the two occupants. Okay, so the first question says the lift is held stationary. Find the value of tension in each cable. Okay, how are we going to do that? Well, remember that if something is held stationary, that means it's in equilibrium. What does that mean about the resultant force? Hopefully you remember that if we're in equilibrium, the resultant force must be 0. Okay, so if we can figure out the resultant force in terms of this missing tension T, we can figure out what T is. So I'll just write a quick hint here. Resultant force equals 0. Can make use of that to answer part A. For part B, the lift now accelerates upwards. Find the new tension in each cable. For that, we need Newton's second law. We need F equals ma. We know the acceleration. If we figure out the resultant force as well, so this one's going to be the resultant force. If we figure out that, we know the total mass, and we know the acceleration, we'll be able to find or form an equation for the tension and solve it. See if you can have a go at this question now. It's not an easy one, but see if you can just set it up, see if you can find the resultant force for each one, and have a go at solving this and finding the tension in each case. And we'll go through that when you're finished. Okay, hopefully you've had a chance to have a quick go at that question. Let's have a go through the answers. So the first part said the lift is held stationary on the second floor. Find the value of T. So it's in equilibrium is the first thing to note. Because of that, as we said, the resultant force is 0. Okay, now the resultant force is made up of this tension, the weight of the lift, and the weight of the two people. Okay, so the weight of the lift, remember that W, weight, is the mass times acceleration due to gravity. So we can figure out the weight of the lift by doing 400 times 9.8, and we can figure out the weight of the people by doing the same thing, 75 times 9.8, 75 times 9.8. So by doing that, we found the weight of each of the components of this system. So the weight of the people is 735 newtons, and the weight of the lift is 3,920 newtons. Oops, 3,920 newtons. So I know that if I do 735 plus 735, 735 plus 3,920, that's the total force downwards. If the resultant force is 0, it must equal the force upwards, which is the tension in cable 1 plus the tension in cable 2. So I've got an equation there which I can solve for T. If I add all these numbers together on the left-hand side, I get 5,390 newtons, and that's going to be equal to 2T, because there's two cables and there's T tension in each cable. So the tension is going to be half of that, so each cable has a tension of 2,695 newtons, just to keep the lift still. For part B, we've been given its acceleration now, and we're going to use Newton's second law to do that. We've already worked out the weights. Now, notice that the tension is not the same in part B as it was in part A. It's a new tension now in the cable because it started accelerating. The resultant force, let's take upwards as positive here. It's important to think about which way we're taking as positive. So let's take upwards as positive. So that means the resultant force is going to be T plus T. They're the upwards forces in cable 1 and cable 2. I'm going to subtract the weights because they're pointing downwards, so we're going to subtract them off, and that'll leave us with the resultant force. So there's the force of the first person, the weight of the second person, and the weight of the lift. That's all going to be equal to ma. Okay, the resultant force equals ma. I can tidy this up a little bit and write 2t minus 5,390, if we simplify that, is equal to ma. Okay, now we know what the mass is, and remember this has to be the total mass of the system, which is going to be 550 kilograms, yeah, because it's the 400 of the lift, plus the 75 of the first person, plus the 75 of the second person. We're looking at this whole lift, so it has to be the total mass of everything, of the lift and everything inside it. And we multiply that by the acceleration, which we've been told in the question is 0.5. I'll do a little bit of rearranging. 550 times 0.5 is 275. Add the 5,390 on, and I get the tension equals 5,390 plus 275, which is 5,665 divided by 2, which is going to be 2,833 newtons, if I round that off. Okay, so you can see the tension in the cable's gone up a little bit because now it's accelerating upwards. It has to provide an additional force to achieve that acceleration as opposed to just staying still. And that's all I've got for you in this lesson. Next time we're going to move on to pulley problems, which relies heavily on understanding Newton's second law, being able to do equations of motion, just like we've been doing in this lesson. So make sure you're happy with this lesson before you move on. If you go to the Solve4x website, we've got loads of practice questions and quiz questions for you to have a look at, all the way from fairly straightforward questions all the way up to exam standard, as well as some sort of exam style questions, some practice papers to have a look at, and also a summary of everything we've been over today. So thanks very much for watching this lesson, and I'll see you again.